The Aurora Borealis, commonly known as the Northern Lights, is a light display in the sky and it is typically only seen in regions of high latitude. They are seen in places like Alaska and northern Canada, but visiting these vast, open expanses is not always easy. Norway, Sweden, and Finland also offer excellent vantage points. During these periods of particular active solar flares, the lights can be seen as far south as the top of Scotland and even northern England.
They are always present, but winter is usually the best time to see them due to lower levels of light pollution and the clear, crisp air. September, October, March, and April are some of the best months to view the Aurora Borealis. The lights are known to be brighter and more active for up to 2 days after sunspot activity is at its highest. Several agencies, such as NASA and the National Oceanic and Atmospheric Administration, also monitor solar activity and issue aurora alerts when they are expected to be put on a particularly impressive show.
There are also southern lights known as the Aurora Australis, but the South Pole is even more inhospitable than the North Pole, so it is often trickier to view these southern lights. The first illustrations that we know of to represent this phenomenon date back 30,000 years, and the lights were originally thought to be a signal of war or destruction. Finally, in 1616, astronomer Galileo named this phenomenon. He used the name Aurora Borealis, taking the name of the mythical Roman goddess of the dawn, Aurora, and the Greek name for the wind of the north, Borealis.
Enough about all this history. What causes this beautiful phenomenon?
This is where physics comes into play.
The sun's many magnetic fields distort and twist as our parent star rotates on its axis. When these fields become knotted together, they burst and create so-called sunspots. Usually these sunspots occur in pairs. The largest can be several times the size of the Earth's diameter. Next, as the temperature on the sun's surface rises and falls, the sun will boil and bubble. Particles escape from the star from the sunspot regions on the surface, hurling particles of plasma known as solar winds into space.
It takes these winds around 40 hours to reach Earth. Particles discharged from the sun travel 93 million miles towards the Earth before they are drawn towards the magnetic north and south poles. As the particles pass through Earth's magnetic shield, they mingle with atoms and molecules of oxygen, nitrogen, and other elements that result in the display of lights in the sky.
Upon entering the Earth's atmosphere, the particles move into an excited state. They emit colors when they drop from an excited state to their ground state following a collision with the Earth's particles. It's important to notice that both the incoming protons and electrons are involved in this. Physics also plays a role in the colors that are emitted in the Aurora Borealis. The colors most often associated with the Aurora Borealis are pink, green, yellow, blue, violet, and occasionally orange and white. Typically, when the particles collide with oxygen, yellow and green are produced. Interactions with nitrogen produce red, violet, and occasionally blue colors. The typical collisions also make a difference to the colors that appear in the sky. Atomic nitrogen causes blue displays, while molecular nitrogen results in purple.
The colors are also affected by altitude. Up to 60 miles high, you will see blue. Above this, you will see purple and violet. At about 150 miles high, you will see green light, and above 150 miles, you will see the red light. Lights may manifest as a static band of light, or when the solar flares are particularly strong, as a moving curtain of ever-changing color.
Earth is not the only place where the aurora occurs. Other planets in our solar system, such as Jupiter, Saturn, Uranus, and Neptune, experience them as well. They also have auroras because of their thick atmospheres and strong magnetic fields. Since these auroras are formed under different conditions, they are different than the ones seen on Earth, but caused by the same types of reactions.
Thank you all so much for watching, and I hope you enjoyed learning about the Aurora Borealis.